Now let us see what is a factor. It's a special kind of vector in R which takes a limited set of values. In simple term, factors are categorical variables. Internally, a factor vector stores the data by mapping each level into an integer. Let's take for example, in this case, these are the regions. This is the region vector. In this region vector, we stored north, south, east, west, west and south. When we create a factor, when we convert this a factor, how can I convert region into factor? We have a function called factor. Factor within the parenthesis, if you give region, it will assign integers to each categorical variable. So here the region east is encoded as 1 since it's the first level, and region north is encoded as 2. Why this transformation is required? By using the simple encoding, much less space is required in the memory. Just remember that factors are actually integer vectors. For each integer corresponds to a category or a level. As I said before, R automatically infers the factor levels from the vector. You passes them and order them alphabetically. Let's work on this one. This is the region. I just created the vector as a region here. We can see all the region values here. If I wanted to see the levels, I don't see any levels here. So what I do is I pass region as an argument to factor function. So it shows, irrespective of the fact that I have 6 region values are there, it shows the unique or distinct values in the vector region, which is nothing but your levels. Levels will show the distinct values of the variable called or vector called region. Right, so east, north, south, these are the distinct values. Now using levels function, we can see how many levels are there: east, north, south, west. Instead of displaying the values along with the levels, if you want to see only the levels, you can use levels of this one. If I use unclass, this one shows me clearly which value is encoded for which region. In the case of east, in the case of north, the encoded value is 2. In the case of south, the encoded value is 3. In the case of east, the encoded value is 1. Why east is encoded as 1? Because R sorts levels alphabetically. Here it sorts the levels alphabetically. So the first alphabetically, if you sort it, the first one will comes east, the second one will comes north. After N, the S will come. After S, the W will come. So that's why when we use levels on region, it shows simply the distinct values of the region vector. Along with that, it will show the encoded value. That's what we could see here. So for north, south is east. So we have only one east, it shows 1. We have west 4, 4, because the west W comes in the last position of your alphabetic. So that's why 4. So now let us see what is there in region factor 1. Region factor 1 is inside the region factor. The first thing is north, right? So north is 2. And the second one is south. South is 3. That's the reason 3 is given. If you use let's say 3, the third one is east. Obviously the third is east. The east is 1. 1 is assigned here. Let's take another example. Let's take defect types: high, medium, low. Here, if I convert it as a factor, we can see the levels as high, medium, low. Actually, we stored the value as high, medium, low, but the levels internally the factor sorted the levels alphabetically. So after H, L will come, after L, M will come. So that's the reason why the level got changed it here. It's not changed. That's how the levels are defined here. High, low, medium. Next we will see unclass. So obviously high will take 1 because in the alphabet of the 3, high comes first in the alphabetic, and L comes next in the alphabetic order. M comes the third. Then why am I getting 1, 3, 2? Here our defect types are high, medium, low. So high is 1 and medium is 3 and low is 2. So that's why it shows 1, 3, 2. Now we can change the order of the levels also. Instead of showing the levels as high, low, medium, I want it to be high, medium, low. So in that case we have something called, inside the factor function, we have something called levels. One second. So high, medium, low. This is the desired level. So you can override the default level which is produced by OR by specifying the levels option. So now high, D, medium, low. Now if I do unclass of this one, high, medium, low, right? So here in this case low is given 1 and medium is given 2 and high is given 3. Sorry, here okay, here low, medium, high. The levels is high, medium, low. So here the least one, the first one in the alphabetic order is given the higher value. The next thing, okay. So in this case L is given 1 and M is given 2. So if you look at this side, yeah, okay. Here low, medium, high, right? So low, medium, high. Here the level supposed to be high, medium, low. So hence low is given 1 and it is the reverse order. So and medium is given 2 and high is given 3. So the levels is high, level, high, medium, low. So now let us check whether defect types 3, this is a low. Low is less than defect type 2, medium. It throws a warning message. So it says it's a less than is not meaningful for factors. It throws an error. If you wanted to change a different order in the levels, so far we are discussing about the nominal variable. Let us look at the ordinal variable. See, if my vector defect type is ordinal, this categorical variable is ordinal type. That case you can specify ordered is equal to true. Let us try this one. Now let us see the levels high, medium, low, because I mentioned high, medium, low. Here high is very high and low is less than medium and medium is less than high. So let's see what value is assigned here, 3 to 1, similar to this one. So here 3 is assigned to this one, 2 is assigned to medium and 1 is based on this order, right? So reverse if you look at it, right? So here the highest value integer is given for the first one, second highest value and third highest value. So here we have only 3 and 2 and 1. That's how it assigns. And even the case of this one, it happened the same way. Now let us check in the case of ordered. Defect types 2 is defect type 2 is medium is greater than defect type 1. No. Let's try with less than. So here we are checking, here we are checking defect type 1 is greater than defect type 3. It's true. High is greater than low. So if you recall the ordinal variable, ordinal the categorical, if your categorical variable is ordinal, then it will have intrinsically order in it. The values in this case the defect types has intrinsically has some order in it. So that's the reason why it is true. Yes, it is greater than this one. High defect severity is high, which is having higher priority than medium. Whereas in this case of region, if I take the same thing, it will throw an error. So it means that it is not meaningful for nominal type of variable. We can't say east is greater than west or west is less than east. So that's what it shows. So we can use levels function in order to assign some short name or the abbreviations kind of thing. For example, instead of specifying north, south, west, east, we can specify the values in the short form like NSWU using levels. Now let us take a look at this one, levels. So this is my levels. Okay, let me do one thing here. What are the levels of my region? Levels of region. Okay. So this is my region and I'm going to convert this as a factor. So what is the levels of region factor? Region factor east, west, unclass. If I unclass it, so the values are sorted alphabetically here. East is given 1 and east is given 1. Look here, you need to look at this one. East is 1 and south is 3 and north is 2 because n comes before s. So here in this case I just wanted to specify the abbreviated values like this. Now if I see the levels of region factor, instead of east, north, south, west, I mentioned about north, south, N, S, W, E. So that's how I specified it. So that's how the levels are maintained here. Now let's take one class. So here, that's the order. It's the same thing. So here in this case, region factor has how many values? 3, 6, right? North comes, east comes first and north comes 2. That's how the values are assigned. The integer values are assigned here. Instead of using levels function to specify the abbreviation for the different regions, alternatively we can use this approach. Inside the factor you can specify the vector name and levels, your levels, this is the level should be maintained. Okay, labels I'm going to assign like this. So north, south, west, east. That's a level made north, south, west. So instead of north, you assign it as n, south, yes. Now let's unclass this variable. We can see unclass rake is NE. Why we are getting NV here? Okay, here north, south. Let's say my region is something like this. Region factor is having what is the value? Yeah, south, west, north, and let me do one thing. So that's the reason here the order is not correct. South, west, north, east. Okay, region factor is based on my region. Okay, here I'm going to specify the labels as S, W, N, and E. Okay, here, 1 second, let me do one thing. Let me remove these two things. Here we have, okay, region, here I made a mistake here, south. So now it's correct because here I wrongly mentioned it, and here I use different levels for region. So these are the levels are available. Here I can. Okay, so this, but internally I can change the levels also, something like this. For example, in this case, so yeah, first I'm just doing west. Here I need to change this one. Two, 1, 3, 4, correct. So I'm clustering. So using levels function, we can specify the abbreviated value for the regions, and alternatively we can use factor function. Within that we can specify levels and the labels. Using labels we can specify the corresponding abbreviated value here. Next we'll see ordered factor. Okay, we already discussed about ordered factor in the case of defect type high, medium, low. So if I compare, high is greater than medium, low, yes, it is true. That's what we have seen it. The next part is you need to be a bit cautious in this case. For example, I have a vector called sales and region. I'm going to create a data frame for these two columns. So my data frame DF has a column called sales and a region. Region is a factor with 4 levels. Okay, so let me check the levels of my DF dollar region. So east, north, and southwest. Let me do one thing. I'll unclass. If I look at here, so east, north, southwest. So the integer values assigned to the class, each class is like this. So here, in this case, the east takes 1 and the south takes 3 and north takes 2. Fine. So far so good. Now let me subset the value by excluding the north. I don't want the north region, and after excluding the north region, in my new data I could still see the level as region. I don't have in my data set, I don't have north region at all, but still it maintains the level. So in order to get rid of this one, we can use drop levels, df1. If I now if I use df1 region, so that this is the order. So now we removed our north region from our levels. So far we discussed about what is factor, what is a nominal factor, how to create the nominal factor, how to change the levels of your factor, and how to create the ordered factor, how to drop the levels, especially when you subset the data. How can you get rid of the level which is not present in your data, especially after subsetting your data.